A very good morning, friends. Uh, in this video, we are going to see how to analyze a structure in Staad Pro. Okay, so the video is going to be long, so I will break this video into small parts so that you can see it easily, conveniently, and also the size will be small, so you can easily download it. Okay. Uh, so before solving this structure in Staad Pro, we are going to see what are the broad steps that need to be followed in Staad Pro. So whenever you are solving any structure in Staad Pro, you need to follow these following broad steps. Okay, every problem these steps will remain same. So what we have right now is a portal frame A, B, C, D, E, F, and G. Okay, so this is a portal frame, and it is subjected to load of 15 kilonewton, 20 kilonewton, 20 kN meter, 2 kN per meter UDL. Okay, so these are the loads, and also you must note that the member A to D is having a flexural rigidity of EI, D to F is having a flexural rigidity of EI, and F to G is having a flexural rigidity of 3 EI. Okay, so EI, 2 EI, and 3 EI. These we must know. Okay, so let us discuss the first broad steps and then we'll start the structure in Staad Pro. So first step is to make the geometry of the structure in Staad Pro. So this portal frame A, D, F, G, okay, this you have to make in the Staad Pro. Okay, so this is called as making the geometry. How it is done? It is done by two methods. Either you can use the snap node B method or the coordinate system that we will see in the Staad Pro problem. Okay, so this is the first step to make the geometry. Second step is to provide the supports. You are seeing that A and G are having fixed supports. So these supports we need to provide to the structure because Staad does not know anything. Everything we have to provide to the Staad Pro. So supports we have to create. Third step is to provide the section and material. This column A to D, beam D to F, and F to G again a column. So these columns are made up of say RCC. So they are having a material RCC and they are having certain size. Say for example here it is given column A to D. EI is 200 by 600. So this 200 by 600 is the section of the column. The beam D to F is having a section of 400 into 600. Okay, so this beam GE is having a section of 400 into 600. Similarly, F to G is 3EI, that is 600 into 600. These are the section and materials of the beam that we have to provide to the structure. Okay, so that Staad can know from which material it is made and what are the sizes of the members. Next step is to provide the loads. Here we are seeing that 15 kN, 20 kN and 20 kN meter and this 2 kN per meter. These are the loads. So these loads we have to provide to the structure. Okay. You must note that 15 kN is a point load. This 20 kN is also point load. 20 kN meter is a point movement and this 2 kN per meter is a UDL. So point load and point movement, these are called as the nodal loads in Staad Pro because these are acting at the nodes. And this 2 kN per meter is a member load. Okay, it is usually it is acting on a member, so it is called as member load. Next step is to analyze the structure. Okay, so everything has been made, everything has been created in the Staad Pro. Now we need to analyze. Analyze means to solve the structure. So by analyzing, the structure will be solved, and then next comes the next step, that is the post processing. In post processing, what we can do, we can draw the shear force diagram, bending moment diagram, axial force diagram, reactions and displacements, and diagrams. Okay, so these can be uh, viewed using the post processing button. Okay, so let us start. So in this first video we will only learn how to make the geometry. Okay, and then next video we'll see how to create the support. In again next video we'll see how to provide the section and material. Again next video we'll see how the loads can be applied, and then we'll see how to analyze the structure and post processing. Right, so let us start. So I have to open the Staad Pro. In this Staad Pro you need to click on the new project. When you click on the new project you will find four options: space, plane, floor and truss. Okay, So what type of structure you must use, space or plane or floor or truss, that depends on the type of structure we are having. Right now we are having a 2D structure, two dimensional structure, a plane frame, that is by using the plane. If you are creating a three-story building or three-story building, you need to select space, because three-story building is in three dimensions, so space. Okay. Similarly, for grid system, floor is used and trusses are used where a truss system is applied. Okay. Then file name, you can name anything. For example, uh, structure structure underscore kp underscore 1. So any name you can give, and this is the location where your file will be saved. Okay. Now here you must use the unit as meter and force as kilonewton. This you must take care. Then next, here it is showing add beam. What does add beam mean? Add beam means when you finish this, it will directly start adding the beam. So it is a fast method of drawing the structure, right? So let us finish this. Finish. Okay. So here our uh, this program has started. Now we can start creating the beams and solve the structure step by step. Okay. So we finish our step 1 here. So हमारा जो पहला वीडियो है वो यहीं पर आकर के फिनिश हो जाएगा. Okay. So now in this second video we are going to understand how to create the geometry of the structure. Okay. स्ट्रक्चर की ज्योमेट्री कैसे क्रिएट की जाती है. तो देखिए, ये स्ट्रक्चर हमने फाइल ओपन कर दी है. फाइल ओपन करने तक का जो है पिछले वीडियो में हमने देख लिया था. अब हमें क्या करना पड़ेगा, हमारे सामने एक थ्री डायमेंशनल व्यू आ रहा है. हमने प्लेन स्ट्रक्चर सेलेक्ट किया था, तो हम लोग क्या करते हैं, प्लेन स्ट्रक्चर को देखने के लिए प्लेन व्यू काम में लेते हैं. तो आप ऊपर आइए यहाँ पर, एंड हेयर यू कैन सी डिफरेंट येलो कलर बॉक्सेज. तो फर्स्ट बॉक्स इज व्यू फ्रॉम प्लस जेड, then this is this. Okay, from plus y and minus y and isometric view. So what is currently activated is isometric view. Let us click on the view from plus z. So now understand the coordinate system first. What is the coordinate system? Coordinate system is x is towards right, y is vertical, and z is coming out of this screen. Okay, so this is the coordinate system that we must know. I again repeat, x is towards right, y is vertical up, and z is coming out of this screen. Okay, coming out of this plane. So this is the coordinate system. Now how to draw the geometry of the structure. Okay, we are going to see two methods to draw the geometry of the structure. First is the easiest method, and then we'll see the second method. So since we have started the file, by default this snap node beam is activated. By default this snap node beam is activated. You can move this window by clicking here. Okay. Now if you close this window, then this snap node beam will be gone. How to start it again? You have to go to geometry, click on the geometry, and the second option is snap grid node, and select beam. Okay, there is also a shortcut here, you can see. Okay, so if I again close it, I simply click on the shortcut snap node beam. Okay, and here this window is again open. Now we will use the grid system to make the structure. Please be informed that do not click anywhere. The moment you click anywhere, it will select the starting point of the beam. So I am not clicking anywhere in the main window. Okay. What we see in our structure is that let me open it. So this is our structure. If you closely observe the dimension, then we find that A to B is 4 meter, B to C is 4 meter, C to D is 2 meter, D to E is 2 meter, E to F is 4 meter, and F to G is again 4 18 to 10 meter. Okay, so we see that all the dimensions are in multiple of 2. Okay, so we can work on a grid of 2 by 2. So let us start the grid. Here we are seeing 10 lines, so we need to edit the grid. First of all, go to the edit. Okay, edit. Here we see that the spacing is, in x direction the spacing is 1 meter, and in y direction the spacing is 1 meter. Okay, so let us make the spacing first 2 meter, because our 2 meter by 2 meter grid would be easy to work with, right? So now we have a grid of 2 meter by 2 meter. Okay, uh, you can see here 10 and 10. So these are the number of lines. Okay, how many lines we want in the grid? 10 is too much as of now, so let us make it 5 and 5, right? Again, move to a structure. We have 10 meter in the vertical direction and 6 meter in the horizontal direction, so this grid will suffice. Okay, ओके, सो हमारी ग्रिड बन चुकी है और हम लोग स्ट्रक्चर बनाएंगे। तो स्ट्रक्चर में हमारा डिस्टेंसेस क्या थे? ए टू बी 4 मीटर, बी टू सी 4 मीटर, सी टू डी 2 मीटर, then again 2 meter, then 4 meter. Okay, so we'll simply click here and we'll make the structure. So uh, click 0,0, then 0,4, 0,8, 0,10, then 10,2 and 10,6, and then click to 6. Okay, and then press either escape, or you can again deactivate it from here. Okay, so both can be used. So what we have seen, our structure has been constructed. देखिए हमारा स्ट्रक्चर जो है बन चुका है। यहाँ पर आइए, देखिए तो हमने जो स्ट्रक्चर था वो स्ट्रक्चर बन चुका है। तो हमारा पहला स्टेप जो था ज्योमेट्री, वो यहाँ करके फिनिश हो जाता है। ज्योमेट्री हम लोगों ने बना ली है। ओके, थैंक यू वेरी मच। अगले वीडियो में हम लोग जो है हमारा अगला स्टेप देखेंगे, जिसमें जो हमारा नेक्स्ट स्टेप था दैट इज हाउ टू प्रोवाइड सपोर्ट्स। तो ज्योमेट्री बनाने का काम यहाँ तक हो चुका है।